So, in the last lesson, we learned about atoms. We learned about how to determine the number of subatomic particles an atom has, protons, neutrons, electrons. But the assumption that we were making was that we have atoms, and atoms have no charge, which means they have the same number of protons and electrons. Protons are positively charged, electrons are negatively charged. And the fact is, most things on the periodic table, when you find them in their natural state on Earth, they are not atoms because they are not stable as atoms. We'll talk about in Unit 3, the next unit, we're going to talk in grueling detail about the why and what's going on with electrons and what makes them stable. And we can go even further if you want to have that conversation. But for right now, just accepting the fact that ions exist and ions for a lot of atoms are more stable when they're in their ion form. So how exactly do these ions form? Well, let's talk about two atoms and look at what happens to them. So lithium. The lithium atom has three protons and it has three electrons. That's why it is an atom. But lithium itself is not stable. It does not want to have three electrons. It's actually more stable when it has two electrons. And again, we'll talk about the why in the next unit. So it will give away one of its electrons. So by giving away one of its electrons, it no longer will have no charge. It gives away an electron, so it still has three protons because it's still lithium, but now it has two electrons. So if you think about it, if we look at this, it still has three protons, it is lithium, but by giving away an electron, it now has one more proton than electron. Well, what does that mean? That means that it has a positive one charge because protons have a positive charge. So instead of writing just plus one, normally we just write plus. If it were to have a 2 plus charge, then we include the 2. But plus implies that it's just a plus 1 charge. So by giving away an electron, lithium has a positive charge. So it is a positively charged ion. We call that a cation. Chlorine, the atom chlorine, has 17 protons always and 17 electrons. But chlorine is not stable as an atom. Instead, it wants an electron. So it'll often get the electron from atoms like lithium, which give it an electron. So instead of having 17 electrons, it's going to accept one additional electron. It still has 17 protons, it's still chlorine, but now it has 18 electrons. So it will be Cl, but now because it has one more electron than proton, it'll have a negative one charge, or we just write this as negative. So the only new concept that we're talking about here is the fact that our number of protons and electrons is now not necessarily going to be the same. And when they're not the same, then an atom no longer is an atom, it becomes an ion. It has a charge. All right, and it has a charge. Chlorine has a negative one charge, lithium has a plus one charge because that makes them more stable. That is how they will exist in the real world. So let's look at some problems here. So this looks very similar to what we did in the last section, except for the fact now that we now have a charge. So quick reminder, the number on top when we're looking at the symbol, that is the mass number. And remember, your mass number is your number of protons plus your number of neutrons. Those are your subatomic particles that have mass. The number on bottom, that 37, is my number of protons. That is my atomic number. So I have 37 protons here. Okay. To find neutrons, I need to take the mass number, 85, and subtract 37 by it. That will give me my neutrons because protons plus neutrons gives me my mass number. So when I do the subtraction, I get 48. So I have 48 neutrons. So here's the new part. I have 37 protons. So I'm going to write this over to the side here. In the past, we've said, oh, that means I have 37 electrons, and we called it a day. But now I'm introducing the concept that rubidium has a plus one charge. So if it has a plus one charge, what that tells me is it has one more proton than electron. So if it has one more proton than electron, and I have 37 protons, that means I must have 36 electrons because I have one more proton than electron. So there's my answer, 36 electrons. Let's look at another. Here, I've got 38 protons, right? So 38 is going to go on the bottom. The number on top is going to be my mass number. So remember, mass number is protons plus neutrons. So 38 plus 50 is 88. And then I'm going to write 88 up top. And then I look at the periodic table and I see that strontium has 38 protons. So I'm going to write strontium right here. And now I look and I see I have 38 protons and I have 36 electrons. All right, so what exactly is this telling me? Well, what this is telling me is that I have two more protons than I have electrons. So two more protons than electrons, that means I have a 2 plus charge. So strontium has a 2 plus charge. All right, let's look at the very last one. Number of protons is 35, so my atomic number is 35. I'm going to put that on the bottom. Okay, 35. My mass number is 80. I look at the periodic table. What has an atomic number of 35 or 35 protons? It is bromine, so Br. When I'm looking at neutrons, remember it is protons plus neutrons is my mass number. So I'm going to take my mass number 80 and subtract from it 35. So that gives me 45 for my number of neutrons. But I have not written the charge of bromine yet. So I need to figure that out. Well, I'm going to erase this a little bit right here. I've got 35 protons. And based on my table, I have 36 electrons. So what I see is that I have one more electron than proton. So since I have one more electron than proton, electrons have a negative charge, so I have a 1 minus charge. And that's all there is to it. We're just adding the fact that instead of atoms having atoms, which have the same number of protons and electrons, I now have ions. So you've got 3 practice problems to do there.